Hello GATE aspirants, welcome to part 10 of GATE quantum mechanics series. Question number 6. An electric field E bar is equal to E naught Z cap is applied to an hydrogen atom in n is equal to 2 state. Ignoring spin, the n is equal to 2 state is 4-fold degenerate, which in the LM basis are given by 0, 0, 1, 1, 1, 0 and 1 minus 1. If H dash is the interaction Hamiltonian corresponding to the applied electric field, which of the following matrix elements is non-zero? Now the interaction Hamiltonian H dash can couple states with delta M is equal to 0 and plus minus 1 due to selection rules for electric dipole transitions, and delta L is plus minus 1. Now for each of these options we will calculate delta L and delta M. For the first one this is Lm, so this is 0 0. For the second state it is minus 1 minus 1, then minus 1 0 and minus 1 1. Now delta L can be plus minus 1 only, and E is along Z axis, that means delta M has to be 0 only. So delta M is 0 and delta L is plus minus 1. So option C is correct. Next question. For a spin half particle, let up and down be the spin up and spin down states respectively. A bar and B bar are given are composite states of two such particles. Which of the following statements is true for their total spin? Now these are spin half particles, so S1 is half, S2 is half, so S can take values 0 and 1. And for S equal to 0, 1, we have to check the states A and B. Now for S is equal to 0, this is a singlet state. And corresponding composite wave function is 1 by root 2, and particles will be in opposite spin. And for S is equal to 1, that will be a triplet state. And corresponding wave functions are given by this. So that means when S is equal to 1, this is given to us. This is wave function A and this is B. So for S is equal to 1, we are getting A, and S is equal to 0, we are getting B. So option D is correct. Next question. The Hamiltonian of a quantum harmonic oscillator of mass m in 3 dimensions is this. The expectation value of R square in the first excited state of the oscillator in this unit is. Now we know expectation value of x square is h cut upon twice m omega 2nx plus 1. That means expectation value of R square will be, this is equal to x square plus y square plus z square. So expectation value of x square plus y square plus z square. So that will be equal to, we can take this h cut by twice m omega common. So this will be equal to 2nx plus 2 plus 1, then 2ny plus 1 plus 2nz plus 1. So totally plus 3. Now in the first excited state, the value of nx, ny, nz, this can be 1 0 0 or 0 1 0 or 0 0 1. So degeneracy is 3, but energy will be same. So let us put nx is equal to 1, ny is 0, nz is 0. So this will be equal to h cut by twice m omega. This will be 2 plus 3, that is 5. And 5 by 2 is 2.5 into h cut by m omega. So answer is 2.5. Answer given in the answer key is 2.5 to 2.5. Next question. Let psi1 and psi2 represent two possible states of a two-level quantum system. The state obtained by the incoherent superposition of psi1 and psi2 is given by density matrix. That is defined like this. Value of C1, C2 is given. The matrix element rho 22 rounded off to 1 decimal places. Rho 22 is equal to psi2 rho psi2. That will be equal to psi2. Then the rho is C1 psi1 psi1 plus C2 psi2 psi2 and psi 2. So this is equal to C1 psi 2 psi 1 psi 1 and then this psi 2 plus C2 psi 2 psi 2 and then again psi 2 psi 2. This will be 0. So and this will be 1. So this will be equal to C2 and C2 is 0.6. So answer is 0.6. Or you can write the density matrix rho is equal to, this is psi 1 psi 2. So that will be C1. Here we have 0 0 and C2. So rho 2 is this C2 which is 0.6. Answer given in the answer key 0.6 to 0.6. Next question 28. The wave function psi of x of a particle is as shown below. Here k is a constant, a is greater than d. The position uncertainty delta x of the particle is. Now this is the wave function. So psi of x is equal to, in this region it is k. Now let us find out these points. This is a by 2 and this is d. So this distance will be d by 2 and we can subtract d by 2 from there. So psi of x value of k, its value is k when it is in the range minus a by 2, this is minus a by 2 and this is minus d by 2. Minus a by 2 minus d by 2 to minus a by 2 plus d by 2. In this range its value is k. Now in this range, this part it is 0. So it will be 0 in this range minus a by 2 plus d by 2 to a by 2 minus d by 2. Then it is k in this range a by 2 minus d by 2 to a by 2 plus d by 2. And it is 0 otherwise. That is when a by 2 plus d by 2, this mod is greater than 0. Outside this region it will be 0. So that we won't consider. So this is the wave function given to us. We want to find out delta x. So delta x is equal to under root of expectation value of x square minus expectation of value of x square. Now delta x, this will be 0 because this wave function is symmetric about this x-axis. So since it is symmetric, its expectation value will be 0. So delta x will be simply expectation value of x squares cube or square root. So this we have to calculate, and this is equal to, this will be equal to psi x square psi upon psi psi. So let us first calculate this denominator and then we will calculate the numerator. So psi psi, this is equal to, now its non-zero value is in only this range. So this will be equal to k square. Let us name these points. Let this point be x1, this point be x2. Then we will consider this point to be x3 and this point to be x4. This point. So this is k square from x1 to x2 dx plus k square and then x3 to x4 dx, and that is 1 dx, so that is x only. So this will be equal to k square and we have x2 minus x1 plus k square then x4 minus x3. So we can take this k square common. Now x2 is this, so that is minus a by 2 plus d by 2 minus x1 is this, so minus minus it will be plus. So this is plus a by 2 plus d by 2. Then x4 is this, so that is plus a by 2 plus d by 2 minus x3 is this, so minus a by 2 and minus minus plus d by 2. This is e. So this will be equal to k square minus a by 2 plus a by 2, that will cancel. So minus a by 2 and minus a by 2. So this is d by 2 into 4. So that is d by 2 into 4, which is 2d. So this is 2d k square. So we are getting this. Now this should be normalized. So if it is normalized, then we can calculate value of k as well. So this should be 1. So from here value of k will be 1 upon under root 2d. So we'll need this value while calculating the expectation value of x square. So this is the denominator part. Now let's calculate for numerator part. And that is equal to expectation value of x square, which is equal to psi x square psi. Now wave function is non-zero in this region x1 to x2 and x3 to x4. So this will be equal to k square. Then we have x square dx in the range x1 to x2 plus k square in the region x3 to x4. Then we have x square dx. And integration x square ds x cube by 3. So this will be k square by 3. And here we have x cube. So that is x2 cube minus x1 cube plus k square by 3. Here we have x4 cube minus x3 cube. And we have values of x1 and x2 with us. So here x1, x2, x3, x4. In each of these terms there is 2 in the denominator and we are taking cube of it. So from each term we can take 2 raised to 3 common and that is 8. So this will be k square upon 3 into 8. This we are taking common. Now x2 is this. x2 is minus a plus d and x1 is minus a minus d. So minus a plus d cube minus a minus d cube plus x4 is a plus d cube minus x3 is minus x3 is this. x3 is a minus d cube. So a minus d cube. So this is k square upon 24. So this will be d minus a cube minus, we can take this minus sign common, so that is plus d plus a cube plus d plus a cube. This minus sign can be taken common, so this will be plus d minus a cube. So this is 2 times of it. So this will be k square by 12 and in bracket we have d plus a cube plus d minus a cube. That is equal to k square by 12 d cube plus a cube plus 3d a square plus 3ad square plus d cube minus 3d square a plus 3d a square minus a cube. And that will be equal to k square by 12. This a cube will cancel. 3d square a will cancel and we'll get d cube plus 3d a square into 2. Now we have already calculated value of k. So k square is 1 by 2d. So this will be 1 by 2d into 2 by 12 is 1 by 6 into we have d cube plus 3d a square. So this will be equal to d square plus 3a square, we are taking d common, upon 12 and that is expectation value of x square and square root of this will be our answer. So square root of this, that is option B. So that is the answer. Next question. Consider the motion of a particle along the x-axis in the potential V of x is equal to F mod of x. Its ground state energy E naught is estimated using the uncertainty principle. Then E naught is proportional to. Now E is equal to P square by twice M plus potential. So it will be plus F of x when x is greater than 0 and that will be equal to P square by twice M minus Fx when x is greater than 0. Now delta x, delta p is h cut, that means delta p is equal to h cut by delta x. So delta E will be delta p square upon twice m plus f into delta x. That will be equal to h cut square upon twice m delta x square plus f delta x. Now we have to find out proportionality with f. This is general expression for E, and we want to find it for the ground state. So for ground state energy, dE by d delta x, this should be 0. That means this will be minus h cut square, this will be 2 here, upon twice m delta x cube plus f, this will be equal to 0. So from here we will get delta x cube is equal to, this 2 and 2 will cancel and minus sign will be gone. So this will be equal to delta x cube is equal to h cut square upon m into f. So delta x will be cube root of this. Now we have energy is equal to h cut square by twice m, and here we have delta x. So delta x can be written as h cut square mf raised to 1 by 3, and we have square here, so this raised to 2 by 3, plus f into delta x is h cut square upon mf raised to 1 by 3. So this is equal to, we have h cut square and here we have h cut square raised to 2 by 3. So 1 minus 2 by 3 is 1 by 3. So h cut square upon m raised to 1 by 3, we have 1 by 2 also here, and f raised to 2 by 3, plus this is h cut square by m raised to 1 by 3, and f raised to 1 by 3, so that is f raised to 2 by 3. So this can be written as half plus 1, so that is 3 by 2 h cut square by m whole thing raised to 1 by 3 f raised to 2 by 3, and this was for E naught. So E naught is proportional to f raised to 2 by 3, so option D is correct. Next question. The Hamiltonian operator for a two-level quantum system is h is equal to E10, 0, E2. If the state of the system at t is equal to 0 is given by this, then this value at later time t is equal to. Now psi of 0 is equal to, this is combination of up and down state, so this will be 1 by root 2, 1, 1. That means bra of 0, this will be equal to 1 by root 2, 1, 1. Now psi of t is equal to 1 by root 2, and energy values are given, so that is E1 and E2. So this will be e raised to minus I E1t by h cut, and this will be e raised to minus I E2t by h cut. So these are the corresponding values. Now let us calculate this. Inner product of psi 0, psi t, and as square. So 1 by root 2 into 1 by root 2, so that is 1 by 2, and that will be 1 by 2's square, because we have here square as well. Then mod of, this is e raised to minus I E1t by h cut, and plus e raised to minus I E2t by h cut, magnitude square. So this will be equal to 1 by 4 and magnitude square, so that is psi star psi, so that is e raised to I E1t by h cut plus e raised to I E2t by h cut into e raised to minus I E1t by h cut plus e raised to minus I e to t by h cut. So this will be equal to, let this be some p. So p is equal to 1 by 4 into, first product will be 1, then this will be 1. So this is 1 plus 1 plus 2 times e raised to, this will be e raised to I minus I, e1 minus e2 t by h cut plus e raised to I, e1 minus e2 t by h cut. So this p will be 1 by 4 into, we have 2 plus, this is cos function, so this can be written as 2 into cos of e1 minus e2 into t by h cut. So this 2 will cancel out, so we'll get this is equal to 1 by 2 plus, this will be 1 by 2, or we can take 1 by 2 common as it is given in the options. So this will be 1 by 2 plus 1 cos of e1 minus e2 t by h cut. So option C is correct here. Next question. Consider a potential barrier V of x of this form. In the range 0 to a, its value is V0. In the range a to b, it is 0, and after b, it is infinite. Where V0 is a constant, for particles of energy E less than V0 incident on this barrier, from the left, which of the following schematic diagrams best represent the probability density as a function of x? Now at this point, V of x is infinity. So at x is equal to b, psi should be 0. So that is first point. So this option is wrong, this option is wrong. Now for x less than 0 and when it is less than 0 and in this region, when it is in between a and b, then that function will be, that wave function will be oscillatory. So it should be oscillatory as it is in case a and b. And in this range 0 to a, it should be exponentially decaying. So it is exponentially decaying in both these cases. And one more thing is there. In this second part, in the region A to B, the amplitude should be smaller than that in this for second region. So here there is increase in the amplitude, which is not possible. This increase is not possible. So only option A is correct here. It will be of lower amplitude in the next region. Next question. Electrons with spin in the z direction are passed through a Stern-Gerlach setup with magnetic field at theta is equal to 60 degree from z cap. The fraction of electrons that will emerge with their spin parallel to the magnetic field in the SG setup is. Here value of sigma is sigma y and sigma z are also given. Now initial state is, it is spin up particle. So it will be, let us assume that it is spin up particle. So that is 1 0. Then psi final, it will be equal to cos of theta by 2 1 0 plus sine of theta by 2 0 1. And that will be, theta is 60, so this will be cos 30 upon sine 30. Now cos 30 is root 3 by 2 and sine 30 is 1 by 2. So probability is psi f psi I mod square, which is equal to root 3 by 2 1 by 2, and here we have 1 0 mod square. So that is root 3 by 2 square, which is equal to 3 by 4, and that is equal to 0.75. And answer given in the answer key is 0.75 to 0.75. Next question. The Hamiltonian of a system is given by this expression. The fourth order contribution to the ground state energy of H is gamma e raised to 4, the value of gamma is. Now here let us find out its eigenvalues. So h will be h is given 1e, e minus 1. So for eigenvalues h minus lambda r is equal to 0. That is 1 minus lambda e minus 1 minus lambda. This is equal to 0. So 1 minus lambda minus 1 minus lambda minus e square is equal to 0. That is lambda square minus 1 minus e square is equal to 0. So lambda square is 1 plus e square. So lambda is plus minus 1 minus e square. 1 plus e square. Now for the ground state, this will be smallest value. So that means lambda is equal to minus of 1 plus e square raised to 1 by 2. Now we can expand this. So Eg is equal to minus sign will be outside. We will use Taylor expansion, and it is 1 plus nx plus n minus 1 x square by 2 factorial plus n minus 1 n minus 2 x cube by 3 factorial and so on. So we will use that. Now first term is 1 plus n is half. So this will be half into x is e square. Now next term is half into half minus 1, that is minus 1 by 2 into square of this. So this will be e square upon 2 factorial is 2. Square of this is e square, square is e raised to 4 and so on. So this is equal to minus 1 minus half into e square. This will be minus 1 by 8, and minus will be plus. So plus 1 by 8 e raised to 4 and so on. So by comparing, we will say gamma is equal to 1 by 8, which is equal to 0.125. So answer is 0.125, and answer given in the answer key is 0.125 to 0.125. So these were all the questions from GATE 2019 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.